Good morning. We're into lesson 9 now. So 9-1 is going to be volume of rectangular prisms, right? So this is three-dimensional. We need to have units cubed, three-dimensional, units to the power of 3, and we'll get into why that is. But rectangular prisms are pretty awesome because we would call them a box, right? In real people land instead of mathematical land, but they have a rectangle base. And then the rest of the sides meet the base at 90 degrees and have a straight line between them, right? And so you may have remembered these from being a young person, right? This has a rectangular base and we can count the number of boxes here, or you might remember finding area is length times width. So we'd have 1, 2, 3, 4, 5. 1, 2, 3. 5 by 3 is 15. And that would tell us the base. And then how many layers of base do we have? 1, 2, 3. So we'd really have 5 times 3 times 3, which equals 45 little boxes or units to the power of 3. Okay, some of that should be a review, how to find the volume of a box. Let's hope so. So let's go here to this example 1. We've got a box here, and we need to find the volume. So if we remember that volume is equal to length times width times height, the length, it could be any one of these. Generally, though, I like to go with the longest part of the base. In this case, it's 3.5. But for simplicity's sake of the calculator, I'm going to put 3.5 because remember we learned 3.5 is 3.5. And then the width is this depth, 1.5. So we're just substituting the values of the variables. And our height then is how far the bases are from one another. So remember the base is down here and the base is up here. So that's 6. And 3.5 times 1.5 times 6, 31. 0.5, and these units were inches, so we're at inches cubed because inches times inches times inches is inches to the power of 3. Okay. Inside of this particular box of sugar cubes are little tiny cubes that are made of sugar. That's how sugar kind of used to be divvied out in restaurants and places, was in a cube, not in a sugar packet. But now we have little paper packets. But inside of there, the little sugar cubes, if each one of those sugar cubes is 1/4 by 1/4 by 1/4, because remember a cube has all the same sides, then it's to the power of 3. You just multiply those all out. 1 times 1 times 1 is 1. 4 times 4 is 16, and 16 times 4 is 64. Inches cubed would be the volume of one of those little boxes. All right, let's try this one. How would we find the volume of this prism? Remember, volume, length, width, height. So we substitute the values of the variables. The length, 5.5. The width is 3. And the height, 15.1. And because the letters are next to each other, that means multiply. 5.5 times 3 times 15.1. 249.15. Units are inches, and because we multiplied them 3 times, that's inches to the power of 3. All right, now that's going forward, and like always, we also need to be able to go backwards. Okay, so let's look at example 2. We're on page 490. Here we have the width, the length, not the height, but they give us the volume. So if we know volume equals length times width times height, substitute the values of the variables. We know the volume, it's 94.5. We know the length, 6. We know the width, 4.5. We do not, however, know the height. So let's simplify this side first. 6 times 4.5 is 27. So this says 94.5 is equal to 27 times h. And if you remember from algebra times, if we need to isolate the variable and the variable is being multiplied by 27, the inverse of that is divide 27, and that will leave us with h. And if we divide 27 on this side of the equal sign, you absolutely must divide 27 on this side. And 94.5 divide 27 is 3.5. And that means the height, oh, we better get our units in here, inches, is 3.5 inches. Okay? Now, let's go over to page 492. And this is a real problem. Like if you run a company and you have to pack packages, or you have a small little business and you're packing packages, this is actually some real math from that. So a storage cube has an edge length of 16 centimeters. And remember, it's a cube, right? So the cube, the volume is going to be side cubed. So we have 16 centimeters. And we need to cube that, okay? Now it'll tell us the volume of the cube. We can get back to that in a minute. It's just, I like when I'm reading to write things down. And it's being packed inside a cardboard box with a length of, box means volume is length, width, height. So with a length of 28 centimeters, a width of 18, and a height of 22. Okay, and when we're done, we'll have centimeters cubed. The extra space is being filled with packing peanuts. Oh, so we're going to put the cube inside the box, and wherever there's extra space, we're going to put packing peanuts in there. And those peanuts cost, what kind of monies is this? 10 cents? 1 cent? 1/1000th of $1? So 2/1000ths of $1 is how much packing peanuts cost per cubic centimeter. So how much will it cost to fill the extra space? So we're going to take the box, subtract the cube, that will give us the extra space. Then we can multiply that by the cost, and then we'll figure out how much money it takes to fill that box, right? So let's first find this volume. 28 times 18 times 22. 11088 centimeters cubed is the box, and the cube is 16 to the power of 3, so I used my little caret button, is 4096, and then we can take those away from each other and get the difference. 6,992, whoops, units missed D. Okay, centimeters cubed. Now we can take that volume and times it by our money. 6,992 centimeters cubed times 0.002 dollars per centimeter cubed is going to give us dollars. Okay, you ready for this? How much do you think? 20 bucks? $2? Okay, so our volume that is left over is 6,992 times 2/1000ths of $1, $13.98. That's a lot of money to spend on just packing the box, right? That's why sometimes the shipping and handling cost is so high. All right, good luck.